Hello friend, you are welcome to UGC EPG Pathshala on quantitative methods in geography. I am Aslam Mahmood, a retired professor from Jawaharlal Nehru University. Today's topic of discussion is probability and probability distribution functions. Today I am going to discuss about the module probability and probability distribution functions, which comes under paper Quantitative Techniques in Geography. Now let me introduce probability. Frequency distribution table give us information about an event either in space or in time. A frequency distribution table is a compact form of information of any background knowledge about a particular phenomena and help us in perceiving future course of the particular event. For example, if we know the pattern of rainfall in a particular area for last 100 years, we can make the judgment about its occurrence next year with some confidence. Similarly, if we know the agriculture productivity of farms in a region for several years, we can generate the productivity distribution for coming years also. Frequency distribution tables, which give us the number of times a particular event occurs out of its several outcomes, are quite helpful in this regard. For example, if we take the old record of the results of a total of 50 matches between two football teams A and B, it may give us the following results as shown in table 1 below. However, before the match is played, if we want to know the result, we can only guess it on the basis of the past performance of the two teams. In the present case, we can say that 50% chances that the team A will win, 30% chances are in favor of team B, and there are only 20% chances that neither team A nor team B will win. If our guess is about a very small number of cases, we will not be very sure. On the other hand, if we have information on very large number of matches, we can make more reliable guess. In geography and in other social and natural sciences also, we have to make certain judgments about an event for which we are not very sure. In such cases, we evaluate the reliability of judgments and choose the one which has the high reliability. The reliability of any such judgment depends on our past knowledge of similar events and their outcomes. The possible outcomes will give us some ideas about its occurrence and will be known as the probability of its occurrence. Theory of probability is developed on the basis of the logic of occurrence of events and applying mathematical logic to measure them. Theory of probability deals with measurement of chances of the occurrence of an event on the basis of the basic characteristics of the nature of its occurrence. It can also be measured empirically on the basis of the past record of its occurrence. In its simplest form, if an event can occur in n number of mutually exclusive and exhaustive random ways, out of which m number of events are in favor of a particular event A, then the probability of the occurrence of event A is defined as probability A is equal to m by n, provided n is sufficiently large. Here, mutually exclusive mean that if one event occurs, the other events of the same set cannot occur. Also, exhaustive means total n number of ways, including all possible ways the event can occur. No event is left in the counting. The example of this could be that from a deck of playing cards, one card can be randomly drawn in 52 different ways, because there are only 52 cards, out of which each set will have 13 ways to be drawn. Thus, the probability that if a card is drawn at random, it will belong to any set, say diamond, is 13 upon 52 is equal to 1 by 4. Similarly, the probability that it will belong to any other set is also 13 by 52, that is equal to 1 by 4. Similarly, there are 4 cards of each denomination in all the sets, and the probability of each denomination is 4 by 52 is equal to 1 upon 30. Axioms of probability. Axioms are the definitional properties. Now, on the basis of the definition of the probability, there are certain evident rules that sum, that is the total of all the probability of all the events, that is sum of the probabilities of all the events will be equal to 1. That is, you add all the possible ways in the event can occur, and you take their probabilities and you add to them, it will be equal to 1. The other axiom is probability of not occurrence of an event is equal to 1, which is the maximum probability, minus the probability of its occurrence. The third axiom is sum of the probabilities of all the event is equal to 1. Probability of not occurrence of an event is equal to 1 minus the probability of its occurrence. Minimum value of a probability is 0 associated with impossible events which can never occur. Maximum value of the probability is 1 associated with sure event, that is events which will always occur. Probability of compound events. The joint occurrence of 2 or more events is also possible. These events can occur in and or form. Like we can think 2 events A and B occurring in form of either A or occur or B will occur or both will occur if they can occur jointly. Another possibility is the event A, that event A and B will occur jointly. There are different laws which will govern the probabilities of these joint occurrence. The first will be governed by what is known as the additive law of probability, and the second will be governed by what is known as multiplicative law of probability. Additive law of probability. If the probability of the occurrence of 2 events A and B are P1 and P2 respectively, then the probability that either A or B will occur is equal to probability of A bracket plus B bracket close is equal to probability of A plus probability of B minus probability of their joint occurrence. It can also be written as probability A1 plus probability 2 minus probability 1 into probability 2. Multiplication law of probability. There are some events which can occur simultaneously also. The probability of such events is the product of their individual probabilities and is represented by P A into B. Thus, probability A into B of the 2 events A and B is equal to P1, which is the probability of occurrence of event A, into probability of P2, which is the probability of the occurrence of the event B. The joint occurrence of probability A into B is equal to 0, that is the events, if the events cannot occur jointly. Such events are known as mutually exclusive events. See, when the events cannot occur jointly, the probability of the joint occurrence of the probability A and B will be 0. That is probability as represented above, probability of A into probability of B will be 0. Example, from a deck of playing card, a card is randomly drawn, give the probability that it is either a spade or an ace. B, either a spade or a diamond. Now, there are two kinds of joint probabilities given in the example above. The case A is that either it is a spade or it is a 4. Then the probability would be the probability of A plus probability of event first event plus probability of the second event minus the probability of their joint occurrence. The probability of occurrence of first events is 13 by 52, that is 1 by 4. The occurrence of the second event is 4 by 52, that is 1 upon. The probability of their joint occurrence will be the probability of first event multiplied by the probability of the second event minus probability of their joint occurrence. Now, the product of the first two probabilities is equal to, the first probability is 13 by 52, the second probability is 4 upon 52. So, multiplication will give me 1 upon 52. Probability of their joint occurrence would be the probability of first event plus the probability of the second event minus the probability of their joint occurrence. The probability of the first event is 1 upon 13 upon 52, and the probability of second occurrence is 4 upon 52, and the joint occurrence is 1 upon 52. Thus, the probability of either A or B will occur is equal to probability of first event plus probability of second event minus the probability of their joint occurrence, that is 13 upon 52 plus 4 upon 52, that is the probability of their individual occurrence minus the probability of their joint occurrence, which is 1 upon 52, and the sum of the expression given above comes out to be 15 upon 52. The probability of the second event is the product of the two events, that is P1, the probability of a card being spade is 13 by 52. P3, the probability of a card being diamond is 13 upon 52. Note that in this case, the minus element is not coming because a card cannot be either a spade or diamond simultaneously. So, the joint occurrence is not possible in this case. So, the product of the two events will not be the case. In this case, it will be 0. Now, we come to another important concept of probability distribution. After having a little basic idea about the probability, let us talk about the nature of probability distribution. The nature of the frequency distribution of any variable depends on the particular process which will generate it. For example, the distribution of size of land holdings of an area will be skewed to the right and will depend on the probability of the size of holdings of an area of an individual, which will decrease as the size will increase. The distribution of the average annual rainfall of an area over a large number of years will be symmetrical, that is, it will be around average in most of the years and equally increase or decrease as we move from either side of the average. Similarly, if 4 coins are tossed together, the results can be tabulated in 5 classes or categories of events. These are, that is, you may have no head in all the 4 draws. This is one category. You may have only 1 head and 3 tails. This is second category. You may have 2 heads and 2 tails. This is the third category. You may have 3 heads and one tail, that is the fourth category, and the fifth category could be that you may have all the four heads. The probability of these occurrences will not be the same. Each event will have a different probability which can be worked out empirically by tossing the four coins together for a large number of times, say 10,000 times or more, and generating the frequency distribution table. Proportion of the number of times in each event occur to the total number of times four coins are tossed will give the empirical probability of each event and is known as empirical probability. That is, empirical probability simply means that you actually do this experiment again and again and again for n number of times, and then note down how many times each option will occur and find out its proportion. That will give you the empirical probability, the probability obtained empirically. Once we know the probability distribution of any event, the advantage of this is that we can make prediction about the estimated value of all the possible events by multiplying the probability with the corresponding event, number of times the event is occurring. For example, if the probability of the average rainfall of an area being between 50 to 60 centimeter is 0.20, in coming 10 years, the estimated number of years with the average annual rainfall between 50 to 60 centimeters can be obtained by multiplying the probability by the number of years, that is 0.2 multiplied by 10 is equal to 2. That would be the expected number of years in which the rainfall will be between 50 to 60 centimeter based on the prior understanding of the probability within this range. We can also work out estimated number of years with any average annual rainfall if we know its probability. For other average annual rainfall also, we can also can find out what would be the probability, what would be the number of years if we know the probability. Theory of probability has its greater applicability in the theory of sampling and inferences also. In any exercise of sampling, we try to generalize about the universe with the help of the findings of the samples. These generalizations are never 100% accurate. There is certain amount of uncertainty involved in it. In such a situation, we make probabilistic generalization. We do not generalize with 100% surety. We generalize with some probabilistic approach and specify the level of uncertainty. Theory of probability also helps us in simulation exercises. Avoiding the long process of tossing the coin, we can also generate the probability distribution using the properties of the theory of probability of the above process. The properties of the theory of probability which have been discussed above. Functional form of a relationship between the value of a variable and their probabilities is known as probability distribution function, and it will be depending on the underlying assumptions behind the process which will generate it. Some of the important probability distributions are discussed below. First one of them is binomial distribution. In the example of tossing of a coin, if we take a general form of n coins, instead of 4 coins, let us assume that we have n number of coins and make the following assumptions: that the probability of head is P, probability of tail is Q, the variable x, that is the number of heads, r tail, is a discontinuous variable. Discontinuous means it can occur only in integers 1, 2, 3, 4. It will not occur in decimal. Occurrence of one coin is independent of the occurrence of the other coins. And the number of coins n is not very large. And the next assumption is that neither p nor q is very small. We can generate the probabilities of the number of heads being 1 or number of heads being 2, that is the variable. The number of heads could be 3, number of heads could be 4, and so on up to n, because n is the total number of the coins. So, either head or tail we can find from either 0, either 1 or 2 or 3 up to n. The general form of the probability which will generate n heads is given as PR is equal to NCX p raised to power x q raised to power n minus x. Now, this is the equation in which if we put the values of n, x, p, q, etc., which will generate the probability of getting number of x number of heads out of n if we draw 4 or n number of coins together, in which n is the number of coins, r is the number of heads, and NCX is an expression which is in fact the number of possible combinations of x number of objects which can be made out of n given objects. For example, if we have 4 objects A, B, C and D, combinations of 2 are possible as AB, AC, AD, BC, BD and DC. And if instead of actually making the combination, we are interested only in the number of such combinations, we can know it through the formula given here of the permutation and combination. In algebra, we have the formula, we will discuss it a little later also, which uses NCX. The formula of finding out the value of NCX uses factorial numbers. A number when multiplied by all the numbers reducing by 1 each time unless we reach 1 is known as factorial number, and factorial 0 is 1. A factorial number thus is denoted by sign given here. Thus, factorial 4 is equal to 4 into 3 into 2 into 1 is equal to 24. That means R factorial 8 would mean 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and all together when multiply will give me 40,320. That is the factorial number of 8. Also, we can write it in notational form. Factorial n is equal to n into n minus 1 into n minus 2 into n minus 3 dot 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 up to 1. And NCX is equal to factorial n divided by factorial x multiplied by factorial n minus x. That is 4C2 is equal to factorial 4 divided by factorial 2, which is x, multiplied by factorial n minus x. N is 4, x is 2, so factorial 4 minus 2, which comes out to be factorial 4 is 24 and factorial 2 is 2, and another 4 minus 2 is also factorial 2, which is also 2. So, it is 2 into 2 is 4. So, 24 upon 4 is 6. So, 4C2 is 6. Now, using the factorial formula for combination, permutation and combination given above, if we substitute the value of NCX in the formula given above along with other constant, the probabilities of different functions P1, P2, P3, P4 to P5, that is number of probability of 1 head, probability of 2 head, 3 head, 4 head and 5 head, can be found in the equation which is known as binomial distribution function. Because binomial, because there are only two options of a throw of coin. That means if even either can occur or it cannot occur. If the coin are tossed, the probability of head is equal to the probability of tail, that is equal to half. We can work out the probabilities as below. The probabilities of the 5 events discussed above with the help of the general formula of binomial distribution. We can work out 4C0 and P is equal to P raised to power 0, that is number of 0 head, and Q raised to power 4, that is no head but all the 4 tail, is equal to 1 upon 16, as 4C0 is equal to 1. Now, the probability of the 2 head, that is P1 head, this is the second option, is 4C1 multiplied by probability of head one time is 1 upon 2 raised to power 1. Probability of 3 tails is the probability of tail is 1 upon 2 raised to power 3. So, this will give me the total is 4 upon 16. Then you have 2 heads and 2 tail. The probability is 4C2, 1 upon 2 raised to power 2 and 1 upon 2 raised to power again 2 will give me 6 upon 16. The 4 head similarly will give me 4 upon 16 and 3 head, and the 4 head will be as 1 upon 16 as shown above. Now, you can verify that these are all exhaustive events of a set of 4 coins when tossed can result in 5 mutually exclusive and exhaustive events. They cannot occur in any 6th event. So, the probability of all these 6 events when is added will be equal to 1. And if we plot these probabilities with the help of a histogram or a bar diagram, we get the probabilities of all the events as shown in the diagram. Properties of the binomial distribution. It is symmetrical when P and Q are equal. If P and Q are not equal, the binomial distribution will be skewed. Mean of the binomial distribution will be NP P. N is the number of the maximum number of value the variable can occur, that is the total number of coins in the present case multiplied by the probability of its occurrence, NP. The standard deviation of a binomial distribution will be under root of n multiplied by p multiplied by q. The binomial distribution is a symmetrical distribution. That means if p and q are equal, it will be symmetrical. We can see that the probability is as low as 1 by 16 for 0 head. As it increases to 1 head, it rises to 4 upon 16, and for 2 heads it goes to maximum of 6 upon 16. For 3 heads again it decreases to 4 upon 16, and finally it reaches the initial value for 4 heads, that is equal to 1 upon 16. One can verify that the sum of the probabilities of all these exhaustive events is 1. Another important frequency distribution function is the Poisson distribution function. In the binomial distribution, we assume that P and Q are either equal or very close to equal. None of them is very high and the other is very low. If we assume that either of the two is very small, that means either the occurrence of the event is very small or it's not occurrence, and number of n is very large, that means event can occur or not occur, and it can occur in a large number of cases, and the average value NP is finite, the probability distribution will become as given below and is known as Poisson distribution. This is the function of the Poisson distribution, where E is a mathematical constant, M is the mean of the variable x, x is the value of the variable. The value of E is 2.718, and it is not taken generally beyond 3-4 decimal. It is a mathematical constant. Poisson distribution in which either P or Q is very small is suitable to generate the probabilities of rare events. That is, as the number of the variables become large, their occurrence becomes smaller and smaller, like number of floods in a river over years, say in 100 years, size of the land holding among the farmers of a district. Now, as you know, in the case of floods, as one flood occurs, it's quite possible that may occur in large number of years. But as number of floods increases, that the probability that in a particular year 2 floods will occur will become again smaller somewhere. But as number of floods increases, say from 10, 15, 13, the probability keeps on becoming smaller and smaller and smaller, making it a rare event. So, Poisson distribution is good for making prediction about the occurrence of rare events. The properties of Poisson distribution. The mode of the Poisson distribution is the integral value between m and m minus 1. It would be, the m is the mean. If suppose mean is say 20, then the mode would be between 20 and 19, somewhere in between 20 and 19. Mean and standard deviation of a Poisson distribution are same, mean and standard deviation, and are equal to m. Poisson distribution is skewed, because it is the rare event which will have a smaller and smaller probabilities as the value of the event increases. So, the probability becomes smaller as we move on the right hand side of the axis. Now, after Poisson distribution, we have a very important distribution known as normal distribution. The above mentioned properties of distribution, that is binomial distribution and Poisson distribution, is that both of them are discontinuous distribution. The probability distribution both, if we instead of having a discontinuous distribution, if we have a continuous variable and neither p nor q is very large and number of n is very large, the distribution, the binomial distribution converges into what is known as a normal distribution. Normal distribution has very important properties and has significant uses in the theory of statistics as well as in geography, and will be discussed in a separate module. Here we are not going to discuss the normal distribution in details. We will discuss it in some other module which is devoted exclusively for the normal distribution and uses in geography. Thank you very much. I hope you got some idea about the theory of probability and the probability distribution. Thank you very much.